Now students, for example, you see here, now this is one transfer function. Now here, now in this transfer function, 1 0 is on right hand side of S plane, and remaining all are one 0 is on right hand side of S plane, and remaining all are on left hand side of S plane. So you know that one or more zeros on the right hand side of S plane. Now this particular system is called as a non-minimum phase system. Okay. If all are left hand side, minimum phase. Now especially the zeros must and should lies on right hand side. Now previously we just see here. Now, if always the zeros, all zeros must and should lies on right hand side of S plane, now that is nothing but a all pass. Know that all pass system, and not only zeros, and there exists a symmetrical pole zero location. Understand or not? See, I just give a clear idea. All are left hand side, minimum phase. All poles and zeros on the left hand side of S plane, minimum phase. Okay. Now, one and more number of zeros, one or more than one zeros are on the right hand side, remaining all are on left hand side. One minimum one and more than one zeros are lies on the right hand side, remaining all the poles and zeros on the left hand side, that is minimum phase. Now this is all pass, especially the zeros must and should lies on right hand side of S plane. This comes under all pass system. This comes under all pass system. If all the poles and zeros lies on, if all poles and zeros lies on left hand side of S plane, this is minimum phase system. Okay, these are this which we already studied in the earlier class. Okay, so all are on left hand side, minimum phase. Symmetrical zeros and poles, all pass, and especially the zeros on right hand side. Okay, and only one and more than one zeros, one or more than one zeros on right hand side, remaining all and poles are, means here I can put one condition, minimum 1 0 must and should lies on right hand side. Right, if more than one zeros also not problem, but there is no need of all zeros must and should on right hand side. But here there is a condition, all zeros must and should right hand side, and there is this symmetrical. Okay, so here 1 0 is on right hand side, remaining maybe on left hand side, not a issue. But minimum 1 0 is on right hand side. 2 or 3 4 also not a issue, right? But no guarantee that all zeros are on the right hand side. There may be some zero is like left hand side also. Okay, clear or not? Non-minimum, minimum phase, all pass. Okay, just go through this once. Now this is a non-minimum phase system. So what I am doing here is I just multiplied, divided with this is S plus 10 by S plus 10, for example. See here, 10 10 cancel means 1. So can I write like this? T of S, which is equal to S plus 10 into s plus 2 by s plus 1 into s plus 5 into s minus 10 by s plus 10. You just check here. This is actually a non-minimum phase system. Am I right? Not? Now this is nothing but a non-minimum phase system. So this non-minimum phase system I can be converting like this. Now see here what happened now here. Now this is all are on the left hand side of S plane. All are on the left hand side of S plane. Therefore this is nothing but minimum phase system. Now this is nothing but symmetrical pole 0 and 0 must and should lies on right hand side. All pass. Now first we will see. Now this is nothing but actually this is non-minimum phase system. Non-minimum phase system. So this non-minimum phase system I can write like this. Okay. So this non-minimum phase system s minus 10 into s plus 2 by s plus 5 into s plus 1. Then this I just multiplied with 10 divided with s plus 10. Then I can make this arrangement. So what we can finally conclude? Therefore, a non-minimum phase system, a non-minimum phase system, a non-minimum phase system which is nothing but a combination of minimum phase system, combination of minimum phase system and all pass system. Now this is the non-minimum phase system. So now phase of non-minimum phase system which is equal to phase of minimum phase system multiplied means addition, phase of all pass system. Clear or not? Okay. So a non-minimum phase system is a combination of minimum phase system and all pass system. Okay. A non-minimum phase is nothing but minimum phase plus all pass system phase. Okay. No doubt. Okay. Now we'll see the problems on compensator. By considering the trans function, this is question number 1. By considering the trans function, g of s equal to s plus a by s plus b. By considering the trans function g of s equal to s plus a by s plus b, if g of s is a lead compensator, this is question number 1, a bit. If g of s is a lead compensator, which of the following is correct? Which of the following is correct? And these are the options. Option number 1, a equal to 1, a equal to 3, a equal to 3, a equal to 3, b equal to 2, b equal to minus 1, b equal to 2, b equal to 1. Now you tell me. So whenever it is a lead compensator, now first you want to indicate that lead compensator means, now first is finite 0, next one is finite pole, this is minus a, this is minus b. So when this combination is coming, when b is greater than a. So first is finite 0, next is finite pole, therefore b should be greater than a. Okay. So which of the following option will satisfy this condition? See here. So if I take a is 3, b is minus 1, so it's not possible, am I not? So if I take a equal to 1, okay, minus 1. If I take b equal to 2, okay, minus 2. Now this is the correct sequence or not? Yes, this is the sequence of which compensator? Lead compensator. This is the sequence of lead compensator. So this is possible when a equal to 1, b equal to, now this is possible when a equal to 1, this is when b equal to 2. Option A is correct. Okay, this is question number 1, a bit. Okay, note down. Okay. Now in the same question he is asking one more bit. Now that bit is now in that question number 1b. Now determine the frequency where the maximum phase will occur. What is asking? Now determine the frequency where phase is maximum. Determine the frequency where phase is maximum. Determine the frequency where phase is maximum. Now g of s, which is equal to s plus 2, s plus 1 by s plus 2, because this is s plus a by s plus b. Now this is the value, this is minus 1, this is minus 2. So this is the time constant, which is nothing but 1. Therefore 1 by tau, which is equal to 1, this is omega c1. Therefore time constant, which is equal to 1 by 2, therefore 1 by time constant, which is equal to 2, which is omega c2. But what is the corner frequency? This is omega c1, this is omega c2. But determine the frequency where the phase is maximum. So that is nothing but omega m, which is the geometrical progression of omega c1 and omega c2. Square root of omega c1 is 1, omega c2 is 1 by 2. Therefore, 1 by root 2 radians per second is the frequency where the maximum phase will occur. Or you can compare with the original thing also. Now g of s, which is equal to 1 plus st by 1 plus alpha st, which is equal to 1 plus s by, if I take 2 as a common, 1 plus 1 by 2 into s. Therefore, if you take t equal to 1, alpha t equal to 1 by 2, therefore alpha equal to 1 by 2. T equal to 1, therefore alpha equal to 1 by 2. Now, what is the frequency where the maximum phase will occur? Omega m, which is equal to 1 by tau into root alpha. Therefore, 1 by tau is 1, 1 by root alpha is root alpha, which is nothing but 1 by 2, which is equal to root 2 radians per second is the frequency where the maximum phase will occur. Okay, no doubt. Okay. Now, similar question. Now, if the transfer function is 1 plus 3ts by 1 plus ts, 1 plus 3ts by 1 plus ts, determine the frequency where maximum phase is produced. Determine the frequency where maximum phase is produced. Therefore, now this is the transfer function. Can I write like this? 1 plus tau 1 into s by 1 plus alpha tau 1 into s, which is equal to 1 plus 3ts by 1 plus ts. Tau 1, which is equal to 3t, alpha tau 1, which is equal to t. Alpha tau 1 is nothing but 3t, which is equal to t. Alpha, which is equal to tt, cancel, 1 by 3. Alpha is less than 1. Therefore, this is which compensator? Lead compensator. Sometimes which type of compensator is also asking. Okay. Now, this is the lead compensator. But what he is asking? He is asking the frequency. He is asking the frequency where the maximum phase will occur, omega m, which is equal to 1 by tau into root alpha, 1 by tau 1 into root alpha. Therefore, which is nothing but 1 by, what is tau 1? Now what is the tau 1? Tau 1 is nothing but 3t root alpha. Alpha is nothing but 1 by root 3. So finally root 3 by 3t, which is equal to 1 by root 3 times of t. Now this is the frequency. See students, this is GATE 2019 recent GATE examination 1 mark question. But actually the 1 mark question is only this. Now maybe ask what is the phase. If he is asking phase, what should you do? If he is asking phase, sine inverse. This is alpha less than 1. 1 minus alpha by 1 plus alpha, which is equal to sine inverse 1 minus 1 by 3 by 1 plus 1 by 3. Therefore, which is equal to sine inverse 2 by 4, 1 by 2, which is equal to 30 degrees. Okay. Now this is the another question. Now if the transfer function h of s equal to a1 s square plus b1 into s plus c1 by a2 s square plus b2 into s plus c2, where a1 equal to b1 equal to 0 and other coefficients are greater than 0. Now if the transfer function h of s equal to that, a1 equal to b1 equal to 0 and all other quotients are greater than 0, and the question what he is asking is which type of filter it is. Now the question is, now this transfer function is which type of filter? Is a low pass filter, high pass filter, band pass filter, band stop filter. These are the options. Now this, then h of s is belongs to, these are the options. Okay. So now whatever he is given, first we can check it. Now h of s, which is nothing but a1 b1 is 0, therefore c1 by a2 s square plus b2 into s plus c2, right? So now we want to draw the characteristics first. Gain versus frequency characteristics. Gain versus frequency characteristics. If s equal to 0, h of s equal to 0, 0, c1 by c2. If s equals 0 means at 0 frequency, now this is c1 by c2. Now, if s equal to infinity, infinity, something by infinity, so h of s equal to 0. So as frequency is increasing, now this value is decreases and will become 0 at s equal to infinity. Now this is nothing but a low pass filter characteristics or not? So h of s belongs to a low pass filter. Okay. And one more thing. This is also 2019 1 mark question. Recent GATE examination 1 mark question. These are the options which is given to you. Now the question is, which of the following Which of the following statement is incorrect? Means which of the following statement is wrong? Okay, this is the question. Okay, what is your answer? See here. Now the lead compensator. The lead compensator means high pass filter. High pass filter means bandwidth is more. Bandwidth is more means rise time is less. Rise time is less means settling time is less. Which one? Lead compensator is used to decrease the steady state error. This statement is the correct statement. Correct statement. But what is the question is asking? Which of the following is the incorrect statement? This is the correct statement. Okay. Now, lag compensator. Lag compensator is used to decrease the steady state error. Lag compensator is similar to, lag is similar to PI. PI controller. What is a PI controller? The I, where there is a word I stands for definitely steady state error is decreases because pollet origin. I means pollet origin. So steady state error is decreases. So this is also correct statement. This is also correct statement. Now, lead compensator. The lead compensator may increase the order of the system. What is the lead compensator? The lead compensator will produce finite zero and a finite pole. The lead compensator will produce a finite zero and a finite pole. Now you tell me the lead compensator produces a finite zero and a finite pole. So because of adding this circuit to already existing system, let us take for example, there are two poles here, second order. Then I am adding a lead circuit to this. So 2 poles and here is 1 pole, 3 poles. So order is increasing. So the lead compensator may increase the order of the system because it will add 1 pole here, 1 pole is here, 1 pole is added. So this is also the correct statement. Now, which of the following is incorrect? Only one option, but anyway, we'll check. Now, this is the lag compensator. The lag compensator always stabilizes the unstable system. The lag compensator always stabilizes the unstable system. Means, it is not always, okay. If any stable system may sometimes, all unstable, but there is no guarantee that it will always unstabilize the system. Lag compensator always stabilize the unstable system. Understand or not? Sometimes it will happen, but not always. Okay. Sometimes the stable system may be affected, and sometimes there is no need of affecting the stabilized system. Therefore, this is the incorrect statement. Wrong statement is this. Therefore, this option is correct. Clear or not? No doubt. Now see here, depending upon the C stands for compensator network, okay? C stands for compensator network. Depending on the compensator network where we are connecting, based on that particular connection, now we can have a different names for that. Now see here this is the compensator circuit is connected in series, therefore this connection is called as series compensation. Okay. Now see here this is the compensator network which is connected in parallel, therefore this is called as parallel connection. Here the compensators network which connected in series and which connected in parallel. So which are connected in series and parallel, therefore this is called as series and parallel combination. Series and parallel connection combination, series and parallel compensator. This is only parallel combination, and this is series compensation. So depending upon the compensator where we are connected, based on that we can have a different types of combinations. Okay, note down this. Now this is a series combination or series compensator. This is a series compensators. These are the series compensators or cascaded compensators. Cascaded compensators. Now this is parallel compensators. Parallel compensator or feedback compensator, because this compensator is in the feedback, therefore this is feedback compensator. Now this is series parallel combination, therefore this is the series parallel combination. This is a series parallel combination, therefore this is called as this is cascaded and feedback combination. Okay, this is series parallel combination or also called as a load combination. This is a load combination. So depending upon the connection where we are using the compensator network, we are using the compensator network in series, therefore this is a series compensator or cascaded compensator. We are using the compensator is in the feedback, therefore this is feedback compensator or parallel compensator. We are using here compensator in a series as well as in parallel, therefore this is a series parallel combination or cascaded and parallel feedback compensation, or you will also call it as a load compensator. Okay, so these are the different types of compensators, but most widely used compensators are lead compensators, lag compensators and lead lag compensators. Okay, that's why we studied only those compensators. Okay, no doubt.